We're going to solve these systems with substitution, which gets to be easier the more that you do it. I'm going to try to make sure that I explain this as well as I can on a video, but know that you can always ask me questions as well. So here we have a system of 3x plus y equals -3 and -2x plus y equals 7. The first step with substitution is that we want to isolate one of the variables in one of the equations. What that means is we want to solve one of the equations for either x or y. So we want to rewrite the equation so that x or y is by itself. So I'm going to take this second equation, -2x plus y equals 7, and honestly here it wouldn't matter because they both have y as a variable that doesn't have a coefficient, so either of these would be pretty simple to do. But this one I can add, and so I don't have to worry about keeping that negative. So this becomes y equals 7 plus 2x. I could have done the other and have y equals -3 minus 3x. Again, it would not matter. If y is equal to 7 plus 2x in that second equation, then in the first equation, when the two are equal to each other, when they intersect, the y in the first equation should also be equal to 7 plus 2x. It should have that same value, and I can use that then to help me solve for one of the variables. So I'm going to take the value of y that I found here, this 7 plus 2x, and I'm going to substitute it for the y in the other equation. Now you want to make sure you use the other equation, never substitute back into itself or you're going to end up with infinite solutions because it's the same line every time. So on this one, I want to do 3x plus, and then this y value is 7 plus 2x. So I'm replacing y with that new value. So now I have 3x plus 7 plus 2x equals -3. 7 plus 2x is interchangeable with y because it is equal to y. But now that it's written this way, I only have one variable in the equation, and I should be able to combine like terms and solve. So I should be able to do 3x plus 2x is 5x plus 7 equals -3. Subtract my 7, 5x equals -10, and then divide by 5. So now I was able to figure out that when they intersect, the x value has to be -2. And if I know one variable, now it becomes really easy to find the other variable. So for the second variable, so here's my system again, same system. I just found that x is equal to -2. So what I want to do now is take either of those two equations and I want to replace x with -2. So I'm going to use the 3x plus y equals -3, although it would not matter. And I'll say 3 net times -2, so I'm just replacing it, substitution, plus y equals -3. Now I only have one variable again, but this time I have the y variable. So I already know x, now I can find y because I'm using substitution with the x. So this becomes -6 plus y equals -3. I'm going to add my 6 to both sides. Now I know my y value is +3. Now I know both parts, so I can substitute or write my ordered pair. So my ordered pair for this system would be -2, +3. This is the ordered pair where they intersect. Now it's really quick to check, and you could do this on a calculator, but I would just want to make sure that this satisfies both equations. And so I would take both equations and replace x and y with -2 and 3. So -3 times -2 plus 3, does that equal -3? So I replaced x and y. That's -6 plus 3, which is -3. So it works for the first equation. And then I could check the second one. -2 times -2 plus 3, does that equal 7? Well, that's 4 plus 3, that is 7. So it satisfies both equations. And so this is a solution to both, and therefore it's a solution to the system. Now, just like we did with graphing, you could also graph these. Now these are not in slope-intercept form, so you would want to get them both to slope-intercept form first. So the second equation would be 7 plus 2x, which we did a while ago. So I could start at 7 and have a slope of 2. So there would be this line. And then for this other equation, 3x plus y equals negative 3, I could subtract 3x and have y equals negative 3 minus 3x. And so I could start at negative 3 with a slope of negative 3. And then you see where they intersect is right there at, ooh, look at that, right where we said they would, negative 2, 3. So it is really the solution. You can see it on a graph, but substitution is a way to do it when you don't have a graph lying around. Let's try another one with substitution. So here we have 2x minus 6y equals 18 and x plus 4y equals 2. I need to take one of the two equations and isolate either x or y. Now in this case, I'm going to want to isolate x on the second equation because it only requires me to move the 4y. I don't have to do anything extra. If I wanted to isolate x or y on the first equation, I would have to move x or y and then divide. Same thing with the second equation for y. So always, if there's one that doesn't have a coefficient or a coefficient of 1, that's what we want to look for. So to get this one by itself, I'm going to subtract 4y and rewrite it as x equals 2 minus 4y. Now I'm going to substitute this value of x into this first equation. So I'm going to have 2x minus 6y equals 18, and I'm going to replace x with 2 minus 4y. Now since it's 2x, I do need to put parentheses here because I'll have to distribute. So once I have it substituted in for x, I'm going to go ahead and solve for y. So I'm going to distribute and get 4 minus 8y minus 6y equals 18. Combine like terms gives me negative 14y equals 18. Then if I subtract 4, I get negative 14y equals 14, and dividing by negative 14 gives me y equals negative 1. So now I know my y value. And once I know my y value, then I can replace it into either of these two original equations to find the x value. So it looks like the second one would be easier to substitute back into. At this point, it doesn't matter. It mattered here when we were substituting for an expression in for the variable, but once we know the actual value, it would not matter. So I'm going to say x plus 4y equals 2, and I'm going to replace y with negative 1. So I'm substituting it in. And then that would become x minus 4 equals 2, and if I add 4, I get x is 6. So there's the second part of my answer. So my ordered pair here would be 6, negative 1. That's the solution to this system. Okay, so is it more efficient to solve negative 2x plus y equals 7 for x or for y? So you're looking at your coefficients. We have a negative 2 and we have this one's a 1. Which one's going to be easier to isolate? And that's going to be y, and that's because it has the coefficient of 1. So you don't have to divide. And that saves us a little bit of work, and so that's what we're trying to do here, right? We want to be efficient. You could totally solve for x. You could isolate x. But y would require less steps and therefore makes it a little bit faster. Now these two systems here represent kind of special circumstances because we have y equals 2, that's one of the lines, and x plus 3y equals 9. And on the other one we have 2x minus 5y equals 13 and x equals 4. So on both of these situations, when you have y or x only, then you're talking about a situation where you have a horizontal or a vertical line. So the y equals 2 is a horizontal line, and the x equals 4 is a vertical line. As far as substitution goes, we already then would know that in this first system, y has to be 2. It's the only option for the first equation. So we kind of get to skip steps 1, 2, and 3 and go straight to substituting in a value. So we would take x plus 3y equals 9, and we would just replace y with 2 because that's the value from the first equation. Then we had x plus 6 equals 9, subtract 6, and x equals 3. So this solution would be 3, 2. For the second system, we know x has to be 4 based on the second equation, and so we would do 2 and then 4 for x minus 5y equals 13. That's going to be 8 minus 5y equals 13. Subtract your 8. Negative 5y equals 5, and divide by negative 5. So y equals negative 1. So this solution would be 4, negative 1. So we really like when they give us a vertical or horizontal line because it saves us so much work. Now, just like with graphs, you could have a situation where you have infinite or no solutions. In this case, when you substitute x and y, both cancel or go to 0. And so you have like 0x or 0y. If it is infinite solution, then the statement that is left will be true. So you'll end up with just values, something like 2 equals 2. Well, that's always true. It wouldn't matter what x or y is, and that means that it's going to have infinite solutions. You may get it down to 0 equals 0. It's still true. It's a true statement. So if it's true with no variables, it's infinite solution. If it is a statement that is false, then it is no solution. There's no way it will ever be equal to each other. No matter what x or y is, you can't make it work. So this is something like 2 equals 0. Well, 2 doesn't equal 0, and there's nothing we can do to fix that. Or negative 4 equals 7. You're going to have some kind of statement that's not true, and there's no variable left that could fix it. And so in that case, it's a no solution. You would have parallel lines. And so you will see a few of those. What I'd like you to do now is to try the 4 examples that are up separately and check them against the key to make sure you kind of have an idea of how to do these. And let me know if you have questions.